Why is it a good idea for lower application layers not to be aware of higher ones? So, the concept of keeping lower application layers unaware of higher ones align with several fundamental principles in software architecture, such as a separation of concern, modularity, and encapsulation. These principles collectively contribute contribute to a more maintainable, scalable, and robust system. Let's talk about what is the beneficial of that. The first thing, let me delete everything, it will be encapsulation. Encapsulation is about hiding the internal state and functionality of one part of a system from other parts of the system by ensuring that lower layers, such as the data access layer or service layer, do not depend on or even know about higher layers, like the user interface or application logic layers. Each layer can maintain a clear boundary of, responsibility. This separation helps protect the system's internal structure and ensures that the in one layer can be made with minimal impact on others. Number two, simplification of complexity. So when the lower layers are unaware of higher ones, each layer can focus slowly or solely on its responsibilities. For example, a database layer should only be concerned with data persistence and should not be complicated with business logic or persistence formatting. This simplification reduces the um, cognitive load on developers and makes the system easier to understand and manage. Number three, reusability. So let's make this quite bigger so for us to read. So layers that are designed to be independent of higher layers are more likely to be reusable. For instance, a service layer that provides business logic but does not depend on specific details of the user interface can easily be reused across different applications of the same organization or even in different contexts within the same application like web and mobile. Number four, we have flexibility and um, modifiability. If a lower layer, if a lower layers are independent of higher layers, it becomes easier to modify or replace one layer without affecting others. For example, the user interface can be completely redesigned without needing to change the underlying business logic. Similarly, it's easier to replace the data storage system without impacting the business rules for the UI, as long as the interface between these layers remain consistent. Number five, we have improved testability. So when each layer can operate independently of the others, it become much easier to test each component. Lower layers can be tested separately using unit tests, which are simpler and faster. This isolation helps in identifying and fixing defects more efficiently. Number six, better performance tuning. So isolating lower layers from higher ones allows performance tuning to be done more effectively. So each layer can be optimized independently for its specific tasks without concerns about unintended effects on other parts of the application. Number seven, we have scalability. So decoupling layers from one another also aids in scaling in the application. For example, if the data layer is separate, it can be scaled independently of the application layer, perhaps by introducing more database servers or switching to a different database system optimized for workload. So, in conclusion, keeping lower layers unaware of higher layers adheres to the design principle of loose coupling, which is crucial for building flexible, maintainable software systems. It enables developers to manage complexity better and adopt the new requirements more easily and create robust applications that are easier to test, maintain, and evolve over time. So that's it for today's video, and see you in the future.